Hey everyone, I'm going to discuss trigonometric function values of acute angles. Particularly, we will be working on the trigonometric function values of special angles. And also, we will be working, or I'm going to introduce cofunction identities. So, you learned about the trigonometric function values of an angle theta. Now, we're going to concentrate this time on the trigonometric function values of acute angles. So, this would mean that the terminal side of this angle theta lies on the first quadrant. And it's also necessary that you have to recall the sign of each trigonometric function values as well as the range values for you to come up with the correct answer. So, we will be working on the right triangle definitions of trigonometric functions. Now, for any acute angle in standard position, so these are the corresponding ratio of each trigonometric function. And this is basically derived from, again, a right triangle. If, for example, this is angle theta and this is a right triangle, if let's say this is x units, this is y, and this is the longest side. Now, coming up with this formula is also recalling the acronym SOHCAHTOA. So you learned this last time. Let us just recall. So for instance, for sine theta, so this represents SO, and the ratio is O over H. So this would mean opposite side or side opposite, which is y, all over its longest side or hypotenuse, r. And then for tangent A, so this is TOA. So this is about opposite side of angle theta y all over its adjacent side. So we're going to consider the adjacent leg instead of the longest side. So this would be y all over x for tangent A or tangent theta. And then we have for cosine here, ka. So, adjacent side all over the hypotenuse. Now, with the rest of with the other three trigonometric function, such as cosecant, cotangent, and secant, so these are the reciprocal of the first three functions. So, for us to come up with the ratio, we will just get the reciprocal. For instance, for cosecant, we know that its reciprocal is sine. So we'll just get the reciprocal. So will lead us to r all over y. Now, let's work on calculating the trigonometric function values of an acute angle. So, for instance, here we're asked to solve for the sine, cosine, and tangent values for angles A and B in the right triangle. So, this will be how we're going to work on that, but this is the illustration. So, we have two acute angles here, angles A and B, and we are asked to solve for its sine, cosine, and tangent. So, we have the corresponding sides. So, again, we have to note SOHCAHTOA. So, let's start with working on sine, cosine, and tangent of angle A. So, this is sine A equals opposite of opposite side of angle A is 7 over its hypotenuse for so. So this would be 7 all over 25. And then cosine A is ka. So that would mean adjacent side 24 all over its hypotenuse. So this is 24 all over 25. And then for tangent A class, so this is TOA. So opposite side, 7 all over its side adjacent. So this is 7 over 24. So these are the sine, cosine, and tangent of angle A. So let's move with B. So sine B, cosine B, and then tangent B. Now, this will be our reference angle, or this will be our angle. And sine B is opposite side of angle B over the hypotenuse. So this is 24 over 25. And then cosine B here. So this is adjacent side of B, which is 7 all over the hypotenuse 25. So we have 7 over 25. And then tangent B is opposite side of B over its adjacent side 7. So this is 24 over 7. Now, if you notice class, take note here that sine A equals cosine B. Also, sine B equals cosine A. Now, we have to note, class, that angles A and B are acute angles. And their sum is equal to 90 degrees because this is a right triangle. We already have one right angle here. So we know that the sum of the interior angles of a triangle, including right triangle, is 180. So if we already have 90-degree angle, which is a right angle, so we will assume that the sum of the two angles A and B is 90. So the relationship about the sum of two angles equals 90 is complementary. So angles A and B are complementary angles, and we will associate this with co-complementary functions, also known as cofunction. So later, I'll be discussing what is cofunction identity. Now, um, here, just to give you an idea, sine and cosine are the cofunctions of each other. So they're cofunctions, as well as secant and cosecant, tangent, and cotangent. So later, I'll introduce to you how to come up with, or how to express, a trigonometric function value in terms of its cofunction. Okay, so again, when we say cofunction identities, for any acute angle A, for example, I've mentioned about cofunctions, and sine A is cofunction with cosine A. So look at the formula here. To obtain sine A, or sine A is equivalent to cosine subtracting the the degree measure of angle A from 90. Why from 90? Because when we say cofunction, this is about complementary functions. So we consider that the two angles are complementary angles. So we have already one angle. So the other pair completing the complementary angles would be 90 minus A. So we have sine A equals cosine quantity 90 minus A. And this applies to the rest of the trigonometric function values. So sine is paired with cosine in terms of cofunction. Cosecant is paired with secant, as well as tangent paired with cotangent. Just to come up with a clear explanation or understanding of cofunction identities, let's work on these example exercises. So writing functions, so we're going to express a function in terms of its cofunction. So write each function in terms of its cofunction. So cosine 52. So cosine is cofunction with sine. So cosine 52 is equal to sine quantity 90 minus 52. So cosine 52 equals sine 38 degrees. Now, when you calculate the approximate value of both sides, they should be equal. So when you press cosine 52 in your calculator and take note of its approximate value and compare that with the approximate value of sine 38, and you will notice that they're equal. So the answer for number 1 is sine 38. Cosine 52 equals sine 38. For tangent, so tangent is cofunction with cotangent. So this is tangent 71 degrees equals cotangent quantity 90 minus 71. So we have tangent 71 equals cotangent 19 degrees. So the two are equal. Likewise, secant 24 is equal to cosecant quantity 90 minus 24. So we have secant 24 equals cosecant 90 minus 24 is 66. Or we have 66. Okay. So that's cofunction. Okay. Now, we're going to solve equations using the cofunction identities. For instance, we're going to find one solution for each trigonometric equation. We're going to assume all angles involved are acute angles. So, in number 1, cosine quantity theta plus 4 equals sine quantity 3 theta plus 2. Since cosine and sine are cofunctions, so we can combine the two expressions and equate with 90 degrees since they are complementary functions. So we have theta plus 4 plus 3 theta plus 2 equals 90. Combining like terms, so theta plus 3 theta is 4 theta. And then transpose the sum of 4 and 2 to the other side of the equation. So this we have 90 minus 6. So 4 theta equals 84. Now divide both sides by 4. So we get theta equals 21 degrees. So when we substitute theta equals 21 to the trigonometric equation here, so we will be able to retain the equality, meaning left side equals right side. So in here, tangent and cotangent are cofunction. So we can combine the two and equate to 90. So we have 2 theta minus 18 plus theta plus 18 equals 90. And then combining like terms, so we have theta plus 2 theta plus theta is 3 theta equals 90. So this will be cancelled. So dividing both sides by 3, we have theta equals 30 degrees. Now, how do we compare function values of acute angles? So we're going to tell whether each statement is true or false. Like in A, sine theta is greater than sine 18. Rather, sine 21 is greater than sine 18. This is a true statement because in the interval from 0 to 90 degrees, as the angle increases, so does the sine of the angle. So this makes a true statement. Since 21 is greater than 18, so we can say that sine 21 is greater than sine 18. Now, on the other hand, cosine 49 is less than or equal to cosine 56. This is a false statement since, on the contrary, as the angle increases, the cosine of the angle decreases. The given statement is false. So, since 49 is less than 56, the lower the value of an angle, the higher the value of its cosine. So this becomes a false statement. Next, so we're going to work on trigonometric function values of special angles. So special angles class are angle measures 30, 45, and 60. Why are they special? Because we can calculate the exact trigonometric function values for these special angles, and we can make use of the trigonometric function values of these special angles in evaluating the trigonometric function values of non-acute angles, particularly obtuse angles. So, um, we're going to make use of these triangles to evaluate the trigonometric function values of special angles 30, 45, and 60. Now, let's consider this equilateral triangle. For convenience, we're going to work on the side length of this equilateral triangle equal to 2. So as we divide equally this equilateral triangle, definitely the length of the base is divided into equal parts. So this will be 1 and 1. So this the interior angles of this equilateral triangle are congruent, which is equal to 60 degrees. So originally, this one is, so these angles measure 60. So since this is divided into two equal parts, so it was divided into two 30-degree angles. Now, this becomes right triangle. So this equilateral triangle is divided into two right triangles. So this will remain 60 degrees. Now, how did we come up with the side length of this equals square root of 3? So working on the Pythagorean formula, we're in the sum on the squares of the two legs of a right triangle is equal to the square of its longest side. So substituting the given here, if this is x, so this is 1 squared plus y squared equals 2 squared. Now, this is the longest side since this is the opposite side of the right angle. So, simplifying the expression, we have y squared equals 4 minus 1. Extracting the square root of both sides, we come up with y really equals square root of 3. So now, we already have the value of x, which is 1, y, which is square root of 3, and r equals 2. We can now calculate sine 30, cosine 30, tangent 30, and the reciprocal, cosecant 30, secant 30, cotangent 30. Also, we will be able to evaluate sine 60, cosine 60, tangent 60, cosecant 60, secant 60, cotangent 60. And then later, we'll work on the TFV of a 45-degree angle. So, by getting one of the right triangles from the equilateral triangle, we know that this is 60 and this is 30 and this is 2 square root of 3 and this one is 1. So we can make use of SOHCAHTOA or we can make use of the ratio. Either will lead us to evaluating the trigonometric function values of special angles. So with sine 30, so this is y all over r, or sine 30 is opposite all over the hypotenuse, so this is 1 half. Cosine 30 is adjacent side, square root of 3 over the hypotenuse. So we have square root of 3 over 2. And then tangent is, let's just work on this bigger uh, figure. Okay, so opposite side 1 over its adjacent side, 1 over square root of 3 or square root of 3 over 3. And then the reciprocal. So cosecant 30 should be 2, while secant 30 must be the reciprocal of square root of 3 over 2. So this is 2 square root of 3 all over 3. And then cotangent 30. So this is originally 1 all over square root of 3. So this should be square root of 3. Now with sine 60, so this will be our reference angle. And opposite of 60 is square root of 3 over the hypotenuse. So this is square root of 3 over 2. And then cosine 60 is adjacent 1 over the hypotenuse. So this is 1 half. Tangent 60. So this is opposite square root of 3 over the adjacent. So this is square root of 3. And then work on the reciprocal. So this should be 2 square root of 3 all over 3. With secant, the reciprocal of 1 half is 2. And then cotangent 60. So this is 1 all over square root of 3 or square root of 3 over 3. Now, before we proceed with evaluating the trigonometric function values of theta equals 45 degrees, let's compare the values of sine 30 and cosine 60. They're equal. Sine 30 equals cosine 60. What else? Cosine 30 is equal to this one, sine 60. And then tangent 30 is equal to cotangent 60. And the rest of the other three reciprocal functions, okay, are meaning cosecant 30 is equal to secant 60. Secant 30 is equal to cosecant 60. And cotangent 30 is equal to tangent 60. Why? This is about cofunction identities. We know that the sum of 30 and 60 equals 90. So we can say that each pair that I have mentioned are cofunction of each other. So we will be coming up with equivalent value from each pair of cofunction. Now, let's consider this another right triangle. And this time, this is an isosceles triangle with two legs equal. Now, if we assign this congruent legs equal to 1 unit, so definitely the longest side is square root of 2. And this is from, again, x squared plus y squared equals r squared from the Pythagorean formula. And this is 1 squared plus 1 squared equals r squared. So this is 2 equals r squared. So extracting the square root. So this leads us to r equals square root of 2. Now, take note that this is 45 degrees and this is also a 45-degree angle. Any between the two angles can be considered as your reference in evaluating the trigonometric function values. So, for example, sine 45. So, opposite of this angle is 1 all over the longest side, square root of 2. So, this is 1 over square root of 2 or square root of 2 over 2. Now, cosine sine 45 class is equal to cosine 45 because the sum of the two angles is 90 and sine is cofunction with cosine. So, this must be square root of 2 over 2. If you want to really prove that they're equal, so refer to this angle, measures 45, and work on the ratio with regard to cosine or the SOHCAHTOA. So that's ka. So meaning adjacent side all over the hypotenuse. So that's 1 over square root of 2, which is also the same with square root of 2 over 2. And then lastly, tangent 45 is equal to opposite side of this angle all over its adjacent side. So this is 1 over 1. So this gives us 1. And then work on the reciprocal function. So sine 45 is the we can work on cosecant 45. And this is the reciprocal of square root of 2 over 2. Originally, this is 1 over square root of 2. So this must be square root of 2, which is equal to secant 45 square root of 2. And then cotangent 45 is 1. Now, obviously, as you can see, each trigonometric function value involving special angles 30, 45, and 60-degree angles are positive because these are all acute angles and the terminal side of these acute angles lie on the first quadrant. So from the previous discussion, you know that the sine value must be positive because both the x and the y coordinates are positive and r will never be equal to a negative value. So r is always greater than 0. So to summarize, we have sine, cosine, tangent of angle measures 30, 45, and 60. So you can work on the other three trigonometric function values by getting the reciprocal of each value here. And this was derived from an isosceles triangle and equilateral triangle. Now, let's try to evaluate or simplify sine 60 quantity squared plus sine 30 quantity squared. So we know that sine 60 is square root of 3 over 2, and we are about to square that, plus the square of sine 30. So sine 30 is 1 half. So this is square of 1 half. And this is equal to 3 fourths for this one. And this is 1 fourth. So this gives us 1. So this is equal to 1. Okay, next. Cosine 30 times tangent 30 plus cosecant 45 times cosine 45. So cosine 30 is square root of 3 over 2 times tangent 30, which is 1 all over square root of 3, plus cosecant 45. So we will refer to sine 45. So sine 45 is 1 all over square root of 2. So its reciprocal is cosecant 45. So this is square root of 2 times cosine 45 is 1 all over square root of 2. So simplifying the expression and combining them, so we have 1 half plus 1 equals 3 halves. So for number 3, how about tangent 45 times tangent 60 minus secant 45 times sine 45? So tangent 45 is 1 times tangent 60, which is square root of 3, minus secant 45. So we will refer to cosine 45, and that's 1 over square root of 2. So its reciprocal is square root of 2, and that's the value of secant 45 times sine 45. So 1 all over square root of 2. So simplifying the expression, we have square root of 3 minus 1. So we cannot combine the two expressions since they are dissimilar. So we separate them by a minus sign. Now, class, you know the trigonometric function values of special angles. Now, it's necessary for you to be familiarized with the exact value of each of these, with each of the trigonometric function values of special angles as we go along with calculating the trigonometric function values of non-acute angles. So we will be using these these values, these trigonometric function values in reference to reference angles. Okay. Now, the sign will no longer be positive since we will be dealing with non-acute angles. So the terminal side will begin on quadrant 2, 3, and 4. So as a result, we'll come up with, we'll be encountering negative and positive trigonometric function values. And that will be our next discussion. So bye for now.